right, so yesterday we looked at transformations. It was a really long lesson, but it was over transformation. So we talked about translation, which was just sliding it. We talked about reflections, which is actually flipping it. And we talked about rotations, which are turning. And those are all ones, even if you don't remember, that you learned in, I think the last grade that they covered is 5th or 6th grade. But it was a nice little recap. So the new one that's new to 8th grade is called Dilations. Dilations. Now, you might have heard of dilations before if you've ever gone to the eye doctor. Sorry, there's something on my journal that's sticky. I don't know what it is, but dilations before, it's when they put something in the eye and it gets bigger or smaller. So that's what dilation is. So we're going to take a few notes on a dilation. So the first thing we're going to ask is, what is a dilation? What is a dilation? Okay. That is when we take coordinates x, y, and they become kx and ky, where k is the scale factor. All right, so what this means is, we're going to draw an arrow, we're going to multiply k times our coordinates. Okay. Now we have two kinds of dilations. We have a reduction, and then on the other side we're going to look at enlargements. Enlargement. Reduction and enlargement. For a reduction, our k will either be greater than 0 and less than 1. Okay? So this is where our fractions are going to be 1/2, 1/3. So pretty much a positive number less than 1. While our enlargements, as you might have predicted, k will be greater than 1. Okay, so that's what a dilation is. It's taking a picture and we're either going to make it bigger or we're going to make it smaller. All right, so a dilation is a transformation that blank or blank a figure to create a similar figure. All right, so in those two blanks are going to be that reduces or enlarge or enlarges. In a dilation, the figure is enlarged or reduced to a fixed point. called the center of dilation. The scale factor of a dilation is the blank of the side length of the image. I know this is a lot of writing. Sorry, the kids in class have a fill in the blank paper. To the corresponding side length of the original figure. The corresponding sides are blank. So I'm going to let you get that copy down. Pause it if you're going to need some more time than I'm giving you. I'm going to give you just a couple more minutes to get that down, and then we're going to go ahead and fill in those blanks. Alright, so it is the ratio of the side length of the image to the corresponding side length of the original figure. The corresponding sides are proportional. Alright, so we are going to look at a couple of examples. Okay, so I'm going to go to the left side. This is on page 49 of our journal. So I'm going to go to the, sorry, those blanks filled in. I forgot I was frozen. Ratio and proportional. So I'm going to go to the left side. And I have two examples, again, that are on grid paper. And we are going to, you're going to copy those images down and on your graph paper. So if you need to go get your graph paper now, go grab them. So there's one of them. Go ahead and start drawing that shape. And we will have 4 graphs altogether. So I'm going to put my first 2 here. And what I want you to do is, obviously, you're going to need more time to get this on your, to get these drawn on your grid paper. And so I want you to go ahead and pause the video now. And I want you to push play once they are both drawn on grid paper and cut out and glued. We talked about having grid paper. Now, if you want copies of this, you're welcome to let me know, and I will put them in the front office for you to come get them. All right. All right, so you should have paused the video and drawn these, or however you're doing if you came to pick it up. So this is going to be an example. We're going to be looking at enlarging first. So these are enlarging. And this is going to be example 1. And this is going to be example 2. Alright, so for example 1, it tells us to use the scale factor of 4. Actually, I'm sorry. Hopefully you, I glued these backwards, so I'm sorry. So I'm going to unglue mine real quick. I'm sorry if I messed you up. I don't know how I did that. I glued them backwards. I'm going to pause this real quick and fix mine, but they are backwards. So I'm sorry. If you wanted to get, if you were glued backwards, because you followed my directions, sorry, and you would like to leave them, just switch the numbers on it, but I like to keep mine in order if I can. So we have figure ABC, A, B, C, and the coordinates of those three are 1, 0, B is 3, 3, and C is 3, 1. So if you refer to our notes, that scale factor is called K, so I'm going to put K equals 4. 4 is bigger than 1, so that tells me it's going to be an enlargement. Okay, and so that figure is going to get bigger. And so what I do is I take this point and I multiply it times that scale factor. So A prime is going to be 1 times 4, which is 4, and 0 times 4, which is 0. B prime, 3 times 4 is 12. 3 times 4 is 12. C prime, 3 times 4 is 12. 1 times 4 is 4. So all I do is multiply my coordinates times that scale factor. A lot of people end up liking this. It's easier. So now let's graph it. So 1, 2, 3, 4, 0. There's my new A prime. B prime is 12, 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's my B prime. And then C prime is 12, 4. So go back to my 12. 1, 2, 3, 4. There's my C prime. Connect. I'm using an index card. I like the index cards because they're not as long as a ruler. And I have a small space here that I work with to do my, on my table to do my video. That's not a good line, but there's my new figure, and I can see it got quite bigger. So question is, did it preserve congruence? Did it keep its same size? Okay, that's what we talked about yesterday. The answer is no. It obviously got bigger. What about did it preserve orientation? So yesterday in class, teaching this, some of the students got really confused on what orientation meant. And so I have a really good example that maybe will help explain it. All right, so just to explain orientation a little bit better, since in class kids, this is a triangle labeled ABC. For some reason, my letters don't show up real well in this video. But yesterday I did a translation, which was just a slide. Did it stay intact? Was it still ABC? Yes. When I did a rotation, it was still ABC, ABC. Yes, even when I wrote to ABC, rotate, it was still ABC. But when I did a reflection, it flipped to a different order, and it flipped to a different side of the shape. And that's when the orientation changed. So I always tell my students, did it flip to the other color? Maybe that will help them understand that. Because look, when I did a reflection, it was A, B, C, counterclockwise. But A, B, C is now clockwise. One time it went counter, this time it went clock. So maybe that helps some of you, maybe not. But I can see that it's still A, B, C clockwise, A, B, C clockwise. So yes, it kept its orientation. Example 2 works backwards. It says, what's the scale factor here? What is our scale factor? With the question mark. So I'm going to take point B. Well, we're going to take point A and B. So point A is the point negative 1, 0. A prime is points negative 1, 2, 3, negative 3, 0. I'm going to show you why I wanted to do B to begin with. B is point 1, negative 2. And B prime is point 1, 2, 3, point 3, 1, 2, 3, 4, 5, 6, negative 6. So what I'm going to look at to find my scale factor is what did I have to multiply this by to get here? So what did I have to multiply negative 1 by to get negative 3? I did times 3. Now the reason I don't like using this one is because of the 0. 0 times 3, because any thing times 0 is going to be 0. But if I look at my B, 1 times 3 gives me 3. Negative 2 times 3 gives me negative 6. So my scale factor is 3. Okay, that's how we do scale factor. All right, I'm going to draw a squiggly line under these two. And we're going to look at a reduction, reducing. We're going to look at two examples of reducing, so it shouldn't be too much. Our two graphs magically appeared. So what I need you to do is go ahead and draw those two. Sorry, I accidentally had cut off a piece of this. I'm making all kinds of mistakes today. I'm sorry, guys. It's been a very, very long week for me, so I'm sorry. But go ahead and draw those two. Push pause, draw those two, and push play when you're done, please. All right, so we have example 3. So this is number 3. And what it's asking us to do here is that's to draw our new shape. So it tells me that the scale factor is 1/3. So I'm going to go ahead and write that as K equals 1/3. And then let's look at our points. So we have A, B, C, D, and I have barely enough room, so I hope you do too. I tend to write really big though. I've always been that way. So we have our points. And you're always welcome to do a part 2, like do 49 part 2 if you need to. We did that before. All right, so 1/3. So this is reduction, so it's going to get smaller. So we're going to look at what happens to each of those sides when they get smaller. So now I'm going to multiply times 1/3. 0 times 1/3 is 0. 12 times 1/3. So look at that on a piece of index card. So 12 times 1/3. To multiply fractions, you know you've got them. Top times top, bottom times bottom. 12 divided by 3. Anytime I have like 1/3, I'm just doing 12 divided by 3. So that's going to be 4. 9 times 1/3 is 3. 9 times 1/3 is 3. 12 times 1/3 is 4. 6 times 1/3 is 2. 3 times 1/3 is 1. 3 times 1/3 is 1. So I'm going to redraw that picture. So we have 0, 1, 2, 3, 4, my new coordinates here. Be sure to always label your coordinates with A, B, C, D. Okay, it's important for anybody looking at your work to be able to tell what side is which. B prime was 3, 3, 1, 2, 3, 1, 2, 3. Ooh, it ends up lining up with my D, which is okay. I just can double label them. 4, 2, 1, 2, 3, 4, 1, 2. C prime, and 1, 1, D prime. So this shape reduced looks like that. So ask myself, did it preserve congruence? I'm going to write that between these two. And the answer is, are they the same size? No. But what about, did it preserve orientation? The answer is yes, because if I look, it goes clockwise A, B, C, D, clockwise A, B, C, D. All right, and for example, our last example, example 4, it tells me that it wants us to find the scale factor. So I'm going to look at my point A. I like A because it's not on one of my axes, and we don't have to look at multiple points. We did on the last one because that's 0, but 1, 2, 3, 4, 5 is negative 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh. And A prime is negative 1, 1, 2, positive 2. So what did I have to multiply negative 5 by to get negative 1? Okay? And so some of you might not be that great at that. So negative 5 times what? So I'm going to look at negative 5 times what is going to give me negative 1. Okay? So to get this, it's the same as doing its opposite of multiplication, which is dividing. So it's going to have to think, what's the opposite of dividing? Opposite of multiplication, which is dividing. So negative 5 divided by 5 will get me 1. So if I do that 1/5, negative 5 times 1 is negative 1. 1 times 5 is 1. Should be just negative 1 there. So my scale factor, so use the reverse of it, use division. So a lot of times you'll see people take the A prime, negative 1, over the A coordinates, or might be easier to say 10 times what will give me 2. 10 divided by 5, well, 1/5 is the same as dividing by 5. Okay, so my scale factor, my K, is 1/5. All right, that's where we're ending for today. So tomorrow is our homework vocab day. I am working on getting test grades back. Sorry, I had some of you grading the online ones are a little bit harder this time. So hopefully tomorrow you'll get, hopefully today you'll get your test grade back from me. But today is a homework and vocab day, so please tomorrow is a homework and vocab day, so please take care of that tomorrow. Be prepared for that. It should take you about the length of a class period. That's about what it takes my in-class students. It's about a class period to do it. Be sure you're taking care of that. All right, if you have any questions, send them my way.